just a very brief overview of Tensorflow, just to get a feeling for the kind of who's in the room. How many mathematicians in the room, or people that class themselves mathematicians? 2, okay, 3, okay. How many people that are actively currently engaged in machine learning? Okay, so a few. Okay. And how many people this is your first time like using Tensorflow or machine learning? Okay, so you're in the majority. That's good. So maybe we pitched it right. Okay, so yeah, just a very brief overview of TensorFlow. Originally developed by the Google Brain team. It really provides a set of primitives for working with tensors. We'll talk about tensors in a moment. And it allows the construction of data flow graph. So hence the name tensors and flow through graph, right? It's open source and it's implemented in Python. How many Python programmers in the room? Okay, quite a few. Very good. All right. What's a tensor? What's this tensor thing? Well, if you go and look on Wikipedia and you look up, this is not for the mathematicians, by the way, you already know this. If you go on Wikipedia, it will give you this definition that says, in mathematics, tensors are geometric objects that describe linear relations between geometric vectors, scalars, and other tensors, which to me seems a little tautological, but then I was a physicist, not a mathematician, so I don't know. A more pragmatic way to think about them is a number, just a single number, or a scalar is a tensor of rank 0. An array is a tensor of rank 1. 2D array, or matrix, as most people will be familiar with matrices, is a tensor of rank 2, and so on, up to n dimensions, I guess. So that's just a handy way of thinking about it. So in terms of visualizing what you're going to be working on this evening, which is digit recognition, here we have like an image which could be an eye, or it could be a 1, and that maps into a tensor this way. So by pixelating that, we can get a set of numbers, so we can turn that into a tensor of rank 2. Now, of course, if we added colour to an image, if we had a cat, because of course the internet is all about images of cats, we would have a rank 3 tensor, because we don't have the RGB dimension added into the tensor. Okay, but talking about tensors in a generic way and being able to process them is what gives us this kind of power. And a flow graph. So we then have a computational flow graph where the nodes are the operations and the edges are tensors. So if you think about these units of data flowing through this graph, you'll kind of be able to perceptualize what it is that's going on. And typically with TensorFlow, we have a construction phase where we assemble the graph, and then an execution phase where we push the data through the graph. Okay, so it's kind of a two-step process. One thing that was interesting to me when I first came across TensorFlow and why it was in machine learning was why Python, right? Because Python is a dynamic, albeit strongly typed language, which you would think would not be super performant. And in fact, that's true, it's not super performant. But it was first released in 91, used for scripting and texting. I've certainly used Python in the past just for doing system scripting and that kind of thing. But it got a bit of traction with Google, and it's gained a lot of traction in scientific numeric computing, I guess because it's a bit nicer than Fortran. Anyone done Fortran in the room? Very good, I'll join you there. Okay, done Fortran, but simpler than C++. But really, and there's a bunch of libraries that support numerical and scientific processing in Python. So SciPy, NumPy, and a bunch of others. The interesting thing about these is that they take advantage of using a lower level plugins. So they're implemented typically in C or C++. So you really have the benefit of having the high performance of those libraries, but the joy of using a dynamic language, which is often much faster and much more productive than using a strongly typed compiled language. TensorFlow architecture, you probably don't need to get too much into this. The point of this slide is really just to point out that you have a higher level Python interface, and underneath you've got a whole bunch of support libraries right down to the GPU layer. So the reason that we use GPUs for machine learning is obviously for parallelization, and because they're very good at doing maths computation. The models, it's interesting actually, the models that you're going to run this evening will run in a few minutes. I tried running them on my laptop just for the laugh, and I think the deep learning one took about 40 to 50 minutes to run on my laptop. So you'll see the power of using GPUs to train models later on this evening. So the typical workflow with TensorFlow is to define a computational graph. You then compile that graph and create a session, and then you run that compiled graph to train your model. Close and save the session. You can then save the trained model off, and we have an exercise later where you can actually save off the model that you've built, and then reloading the model in is much faster. So it's the key point to understand with working with machine learning is that training the model is what takes the time and the compute resource. Actually using the model is much faster, and you can actually download a trained model and run it on your laptop, and it will run in very, very, very quickly. So this is a very simple TensorFlow program for adding two numbers together. If you think that's a bit complicated to add two numbers together, you're right, it is, and you wouldn't normally do that. But the point is that this is to outline the general structure. So you're building a session and then pushing your data 2 and 3 through this model to get a result. So what's happening here is you're dropping down to a lower level, building a graph, and that's happening under the hood, and then you're pushing data through that graph. And you'll see as you inspect the code later on that this gets a little more complicated, but the underlying model is still the same as you use TensorFlow. So I think yes, it is silly. We've done that. I think the next thing now is to move on to the example workshop, which is the first one, which is the softmax example. Has everybody got Wi-Fi connection now? Yeah. Excellent. I'm delighted. So you'll need to go to. Let me just bring up the URL. So if you go to github.com Cork AI Meetup 1. The README on there will give you a set of instructions for workshop. There's 2 workshops on there. We're going to work through the first one. There's a basic exercise and a couple of other exercises on there. So we'll come around as people are working on them and make sure everyone's okay, not stuck. And we'll give it maybe, 15 minutes for people to work through that?
Yeah, actually, it might be good for Chris just to say a couple of words.
Sorry, yeah, we'll let Chris talk about that. Sorry, Chris, please, come on.
So the very first step in the tutorial is going to be getting your AWS account set up so that you can log into an AWS session.
Chris, please.
And use a GPU. So this is Chris Johnson, who is very kindly sponsoring us from AWS, and he's the guy to talk to about AWS.
Hi, I'm Chris. I'm a solutions architect at AWS, and despite the accent, I actually live here in Cork.
There's 2 of us, right? So
I'm here to help, right? I'm here to support. So I've got $50 credits for everybody here today. The workshop in total will probably cost less than $1.50. But the credits I can give you now will cover all AWS services, and you can use them freely through to next year. I'll leave my email address up if anybody's got any questions. As a solutions architect, my role is to work with customers and help them reduce costs, improve security, all those good things. But yeah, just give me a shout, all right? One thing, please do follow the workshop and make sure the instances are terminated or stopped once you finish, because they will carry on billing if you leave them running, all right? But anyway, I'm here, and thanks very much.
And also, if anybody did not set up an AWS account in advance and you still want to work through the tutorial, Chris has some pre-set up accounts that he can let you log on to. So if you hop over to Chris, he will help you with that.